Hello everyone, a video on algebraic identities from class 9 in which we would talk about squares and cubes of polynomials. So watch it carefully. So we are discussing identities on product of binomials. The first one we have for x plus y whole square. And x plus y whole square would be x square plus twice of xy plus y square. Next one is, if we go for x minus y whole square, that would be x square minus twice of xy plus y square. Then we have product of x plus y and x minus y. That would be equal to, on simplification, it becomes x square minus y square. The next one is product of x plus a and x plus b. This would give you x square added to a plus b times x plus ab. All this can be obtained after simplification. And finally we have a trinomial square, which is x plus y plus z whole square, which would be equal to x square plus y square plus z square plus twice of xy plus twice of yz plus twice of zx. Dear students, the first four identities on squares of binomials we are already aware of. We know the application. So we would be picking up identity on square of a trinomial, which is x plus y plus z whole square. It's equal to x square plus y square plus z square plus twice of first two terms xy, then twice of yz, and finally comes twice of zx. Right? Let's pick one example from your exercise. This is question 4, exercise 2.5, question 4 I am taking. Part number 4. It is thrice of a minus 7b minus c whole square. Now observe this very carefully. If I take this as x, y, z, then x is 3a, y is minus 7b. We can rewrite it as thrice of a plus minus 7b plus minus c, and then we would square it. So straight away apply this identity. This becomes a square, which is thrice of a square, plus b square minus 7b whole square plus c square plus twice of product of 2. First two, 3a into minus 7b. Then comes product of, I'll just write it here, twice of yz. What is y? Second term and third term. And finally twice of zx, z which is minus c, and x which is thrice of a. Let's solve this. This is 9a square plus 49b square, because minus 7 squared would become positive 7, plus c square, plus minus would be minus product of these numbers. 3 times 2 times 3 would be 6, and 6 into 7 is 42. 42ab. Then negative into negative would remain positive, would become positive. One positive is already there, so twice of 14bc, and plus minus is minus. Twice of 3 would be 6ca. So this set of terms, it's a polynomial. This polynomial is expansion for square of a trinomial. I'm sure it is clear. Okay, now let's say at times we may be given reverse of this formula. Now when I say reverse of this formula, we may be given expanded form and we would be asked to put it in factorization form, or we would be asked to factorize it. Let's again deal with the same exercise. I'm taking question number 5, part number 1, exercise is again 2.5. See, it says factorize. Factorize what? 4x square plus 9y square plus 16z square added to 12xy minus 24yz minus 16xz. So as you can compare it, there are 3 perfect square terms. Let's put it in this whole square formation. This is nothing but 2x whole square. This is nothing but 3y whole square. 16 perfect square for 4z whole square. Then x square plus y square plus this z square is done. What do we have next? Twice of a, which is 2x, into b, which is 3y. But now this is fine. 2 times 2 would be 4 into 3, 12, and xy. This is positive. Look at the next term. It is negative, and even this term is negative. 2 terms have got negative sign, but our formula has got positives. So now we would focus on that particular variable which would have make this term negative. This is yz, this is xz. We see this z common in both. It's present in both the terms. And this z only has made these 2 terms negative. So what if I write this as minus 4z, because I know minus 4z times minus 4z would remain 16z square, right? So this is not going to make any difference, but over here our purpose would be, our aim would be fulfilled. Let's see how do we change it. Twice of xy, it's done. Twice of first term and second term. Then comes twice of 3y and minus 4z. Just check this. 3, 2 would be 6. 6 into 4, 24 with a negative. 24 with a negative is there. Product of yz would make it yz. So even this term is done. Then comes twice of zx. Z, the last term. Minus 4 times z, x, which is twice of x. Just cross check this even. 4 into 2 would be 8 times 2 would make it 16. Positive, negative would be negative, and product of zx or xz would be same. So our formula has been arranged. Now we know the values of a, b and c. A is 2x, b is 3y, c is minus 4 times z, and this is all in perfect square form. And in the next step, it can be written as twice of x plus thrice of y minus 4z whole square. So these are the factors, or this is how you would factorize this complete polynomial, or this complete expansion has been put in factor form. We'll be talking about identities on cube of binomials. So the first one we have is x plus y whole cube, which would be equal to x cube plus y cube plus 3 times xy into x plus y. And next we have for x minus y whole cube, which would be equal to x cube minus y cube minus 3 times xy into x minus y. Now kids, how did we obtain this result? You know, we have discussed this in class, so I'm just briefly recapitulating it. X plus y whole cube indicates that x plus y is multiplied 3 times. Okay, so when you multiply it 3 times, you would see most of the terms would be clubbed. The like terms would be put together. 2 terms for perfect cube, which are x cube plus y cube, would be obtained, and the remaining terms would be added, and from there thrice of xy comes common and x plus y remains in. Same way, if it is x minus y whole cube, it would be x minus y multiplied 3 times, and
process would be same, you would get the result in the similar manner.
Now let us check the expansion for x plus y whole cube and x minus y whole cube. So we would pick up one question from exercise, from the same exercise. This is question number 6, part number 2 I am taking. It is 2a minus 3b. Okay, this is a binomial and we need to cube it. So how would you simplify this? Checking out these two identities which are given, one can make out that this is a minus b whole cube, or you can say x minus y whole cube. Just expand it according to the identity. This would be first term cubed, a cube minus b cubed minus thrice of, when it says xy, thrice of first term, second term, and then x minus y, both the terms to be copied as such. Next step, twice of a whole cube would be 8a cube. This is 27b cube. This is 3 times 2 would be 6, 3, 18ab, and here we have 2a minus 3b. And in the next step, it would be 8a cube minus 27b cube. Let's simplify this bracket also. 18 times 2 would be 36. A into a is a square with b. This is negative, this is no sign. No sign means it is positive. So this becomes minus. Minus into minus would be plus. So 18 times 3 would be 54 ab square. So here is the expansion for 2a minus 3b whole cube. At times we may be asked to go in the reverse of it, as we have discussed it for the previous case. Now expansion is given, we need to put it in factor form. So when you compare it, I have taken question 8 fourth part, which is 64a cube minus 27b cube minus 144a square b plus 108ab square. Negatives over here indicates that this would be a cube minus b cube minus thrice of ab into a minus b formation. But let's see what is the actual value for these two, so that it can be put in this factor form. 64 we know is a perfect cube. It can be written as 4 cube. So this is 4 times a whole cube. 27 is 3 cube minus 3 times b whole cube. So we are going on the same track. This is x cube, which is 4a cube minus y cube, which is thrice of b whole cube, then minus 3 times a, which is 4a, 3 times a, which is 4a into b, which is 3b, and then comes a minus b, or x minus y, which is 4a minus 3b. In the next step, what would you do? We would simply check. We are actually just verifying whether this expansion or this rearrangement which we have done over here or even over here, does it match with this given polynomial? If it would match, then undoubtedly we would express it in this form, which is x minus y whole cube. When I say x, it means the first term minus the second term whole cube. So let's see. 4a whole cube, we know 64a cube minus 3b whole cube would be 27b cube, undoubtedly it's right. Let's check this. 3 times 4 would be 12. Let me write one more step for this. 4 times 3, 12 into 3, 36 ab, and 36ab needs to be multiplied by 4a minus 3b. Now this multiplication we would not be actually doing. We would just verify that will we get the same result or not. 36 times 4, if you know is 144. Okay, so this would become 144. A times A is A square B, and negative into negative would be positive. 36 times 3 is 108 AB square. So we can observe that our last two terms are exactly same, and first two terms have given us the values for A and B. So this is 4A minus 3B whole cube. That's how polynomial which was expressed, which was actually in expanded form, has been written in factor form.